let's go through LeetCode 1422, diagonal traversal 2. And for this question, it gives us a list of these integer nums. And it let us to have a diagonal traversal and return the traversal result. So it's an integer array. Let's take a look at the example 2. Let's see. It has in this list it has 3 list of integers. 1, 2, 3, 4, 5. There are 5 lists of integers, and what it iterate. If we look at the picture, it iterate from the bottom left to top right, and so what's it in this line? It have the number 1, so it will be the first one. And this line, it has 6 and 2, right? So it goes through this line. And for example, this line 8, 7, 3, and this line that is 9. And in this area there is no numbers until it hit 4, so it will be 9, 4. If we look at the example, we'll find for each line, there is some kind of rules we can follow. For example, 6, 2, right? It has for 6, it has row to be 1 and the column to be 0. And 2, it have the row to be 0 and the column to be 1, right? So I see the row and the column, the sum is equal. And also 8, 7, 3, they have row plus column equals 2. So so the iteration is that the kind of sequence will be we have something like the row plus column, and it will have some kind of order. For example, this one smaller one will be always ahead of the sum, which is greater one, right? And so we can use a map to store. For example, key will be an integer, which will be row plus column, and the value we're going to have a list. And what we store is in the list is the number. And we iterate every list. So we'll find what the iterative order is that we're going this way, right? So we want to have those kind of elements be stored in this list in the way we iterate. For example, if we go from this way and this way, right, we put in this list. For example, the first one is 1, the second one is 2 and 6, right? And the third one is 3, 7, 8, right? We'll find this kind of order is different, is in a reverse order. So what we want is not a 1, 2, 6, it's a 1, 6, 2. Well, see, this one is reversed to this, and 3, 7, 8 will be reversed to 8, 7, 3, right? So this will be our result. So in this list, we should, when we compose, we should reverse its order. And for map, right, this is map, and we always want to iterate from the smallest one to biggest one. So there are 2 approaches. One is that we have map to be a tree map, right? Tree map, the time complexity is let's see how many keys, right? K, log K, right? So it's not linear. So we can use another hash map, which is called a linked hash map. The order we store the key, the keys in the hash map is ordered, and the order we store the key is is related to the order we place the entry into the map. So after in this way, we can have linear operations. So let's begin to write code. We're going to, as we talk about, we're going to use a new map, which with a map, and the map have list. New, we're going to use a new linked list map, because we want to the key in our order. The order will be the order we place the entry. So let's say for I I smaller than means dot size. We get its list out. We have a length equals the list of the size. Let's say for into j is there j smaller than length j plus plus map compute if since I plus j right a goes to new array list add list get j, right? So we add those kind of values into this list. So after we get this, we're going to have a result. New int count, right? We can have a count to be calculated here. Count plus two less, right? So we have an index equals 0, and for each list map dot values. Let's see. We will see the order in this list. Actually, it is the reverse order. You see, when we place the items in the list, we place 3 first, because we go this kind of direction. 3 will be first, and then we meet 7, and then we meet 8. So it will be 3, 7, 8, right? But we'll see the example that it should be 8, 7, 3 should be a reversed order, right? This is a reverse. So we should do for int j equals list of size minus 1, 3 greater equal to 0, j minus minus. And our result index plus equals list get 0. And then we return result. Sorry. Not the sorry. I think this data structure should be linked hash map. Link hash map. Okay. Link hash map. For this kind of data structure, when we place items entries to the map entry or trees will be kept the order we placed. Linked hash map. Yes, it will be pretty fast. And in this way, we use the linked hash map. This kind of is a linear operation. Every insert that is O1 operation, right? So you will see the linked hash map. This kind of it is linear, right? So it will be if we have n objects, n numbers, or we'll see the total number is n, right? So this will be O(n), and also we just iterate those kind of lists that will be O(n). The space complexity is also linear data structure that is also O(n).